So the topic is adding a math spell check feature to Lix, which is a operation that's applied. The point is you select some typesetting input that corresponds to the typesetting for a Fitch derivation, and then well, actually, since Fitch derivations are totally self-contained. The way it works is that you just have to check each line, and that's it. You just have to check that each line is correctly formed. You don't need some extra metadata that indicates which theorem is being proved, for example. It's just the nature of the way this particular logical deduction system works. That may be true in general for logical deductions, however. But the point is, you select the typesetting instructions, you go to your menu, you select math check or inference check or rule check or inference rule check, and then it crunches and tells you if you have any errors in your derivation. That's all it does. So the question then is how to get there, and what sort of development trajectory to take. What is the ideal way to achieve this outcome of this new feature being added to Lix? So that's the outcome. That's looking at the outcome for an open source project. Now, the thinking here is that's perfectly fine, sort of final outcome. However, the thinking is that there may be other applications or other interests or other curiosity regarding checking application of inference rules. And the thinking here is that you would have a standalone application or a JavaScript single-page application that performs this task. One of the issues that is going to come up is the extent to which a library of derivations or theorems has to be maintained in order to give the user the tools and the power and the techniques that they want to use. And this is an issue that I haven't confronted yet. One of the aspects of this issue is how to incorporate axiom schemas and theorem schemas into the Fitch derivation. Now, I want to just point out, one of the things that hasn't really been first of all, let me just say, there's one obvious way in which the axiom schema can be applied to inference rules in the Fitch derivation, and that is as a function. So we simply use the lambda calculus to denote a Fitch derivation schema as a function that takes parameters and then returns a Fitch derivation. What this means is, in a sense, adding the Fitch derivation as a data abstraction to the data-directed programming style of structure and interpretation of computer programs. I think that, first of all, 5 chapters in a computer science textbook, very small number, one hand, okay? There's a lot of room. Chapters 6, and I've been thinking about this a lot, chapters 6 and 7 especially. Not just one chapter, but 2 extra chapters. What are they going to be? What are the most important aspects of computer science that do not appear in that textbook? 1. LR parser and GLR parser, converting source code to tuples. Okay. So, I think they're called like S expressions or structure. What do we call them? They're called S expressions. Or symbolic expressions. All right. That's chapter 6. Chapter 7 is Fitch derivations. Okay. The point of the Fitch derivations is that it gives us access to the inference rules. And this is, this is sort of, I guess it's going to be, I don't know, maybe it's our connection to mathematics through formal mathematics. Okay. So this is how we finally get connected back to set theory. And I think chapter 8 would then be set theory. So you've got LR parsers, GLR parsers in chapter 6, inference rules and Fitch derivations in chapter 7, and axiom schemas and theorem schemas. Chapter 8, set theory, ZFC set theory. So these are chapters 6, 7, and 8 for SIGP. Now, of course, this is all sort of silly. This is using one book as an inspiration for another. Maybe it's not so silly. You could get cosmic about it and call it the New Testament. No need for that. This is all about joining computer science to mathematics, especially modern mathematics. I think that direction, the direction that goes in, is very much what's going to be important there is adding a typesetting facility to Scheme. And the thinking here is that what this is going to do is that this is going to ease the, I don't know how to put it, maybe ease is the wrong word. It's going to add comfort, it's going to add luxury, it's going to add beauty, and it's going to, I think, be powerful in terms of, the kind of interface it offers the user. And I think this is sort of the challenge, I think, is to say that Scheme is, in a sense, good enough for joining mathematics to computer science, and that Scheme is probably the ideal language for introducing a standard for symbolic mathematics into programming. And I could go on as to why I think that is, and so on and so forth, but I think the point here is that the proper way to think about the Fitch derivation is as a data abstraction that can be manipulated using the same techniques that we find in SICP.